Hello, Zulu. How are you, my friend? How's it going? So I'll explain you the task that you proposed in the last classes regarding the linked list. So in this one, first of all, I changed the interface to be able to implement the different methods that you suggest or the task must be implemented, like insert ordered, is empty, remove all, get mouse, get graph. So the implementation of those different methods was in the insert order. First of all, we have to create a new node. We have different validations to know obviously if the node is empty or not. If first of all, if the node doesn't exist, we have to head equal to null. We have to change the head and the tail pointed to this new node. And if the node exists, we have to compare if the data is minor or equal to 0 and change properly according to the case to insert at the end, or if we have to insert in the middle, we do a comparison of the different values that we have. To remove, we use I use a current value to equal a head to know what is the value, and different conditionals to found this one at the head or on the tail. And then finally remove the value. Remove all is pretty much the same, but in this one, remove all the occurrences. The get nodes, I use two variables to be able to know how many times the data repeated. So I increment this one with the data punto equal is equal to the value, and the sort descending. In this one, I we implement the first method to insert the data in order. So in this one, only I have to reverse that one because the data obviously is in order. To test this one, I also change the menu with the new methods. I implement at isEmpty to doesn't allow the user to execute this method to search for a value if the list is empty. And to prove this one, for example, we run the program. In this moment, the list is empty. No, sorry. In a moment. In this moment, the list is empty, so we don't be able to search, to show the list, to remove all the occurrences. To test this one, I create this value according to the task. This is the list. We have the values in order. If we show this one in the same in order, but this doesn't change the originally. If we show the list again, it's the same list. To reverse this one, we have to implement with the number 4. The list has been resorted. If we show the list again, this one is reverse. Show no show mouse, only show axis, like the task said, and show graph. And it will change these values with the other one to prove that the mouse change. If we show the mouse, we get 3 and 6. If we want to remove an element, an occurrence, for example, with 1990, the 9 doesn't exist in the list. But if we remove, for example, 1 has been removed from the list, we can remove all the occurrence like the 3. Occurrence of value 3 has been removed from the list. That's it, Zulu. Thank you.